Hello class, this is lesson 1.4, slope-intercept equations of lines. Now, I'll begin by giving you a formula. This is called the point-slope formula. And it is the following. It's y minus y1 equals m x minus x1. And this is the equation of the line with slope m and the line passes through the point x1, y1. Okay, so we can use this formula to get an equation of a line. Now, you may remember in lesson 1.3, I told you if you're given 2 points, you could find the slope and the y-intercept. But then I never did an example showing you how. All I did was show you how to find the slope. And that's because I was getting a little bit ahead of myself. In this section, we will learn to find the slope and the y-intercept if we're given 2 points. And we can use this formula to do so. So what I'm going to do here is just give a couple examples using this formula. We'll start out easy, and then we'll get into a little more tricky examples. So, for example, find the equation of the line with slope 3 and that passes through the point 1, 2. Well, I'll put the formula we use in blue. That's y minus y1 is m x minus x1. And by the formula, put the slope here, and then this is x1, this is y1. Right, so we simply plug in y minus y1 equals m x minus x1. Now this is the point-slope form of the equation. If we wish to write it in the y equals mx plus b form, the slope-intercept form, we could just move some numbers around, right? I could add 2 to both sides of this equation, giving us y equals 3x minus 1 plus 2. Next, I could multiply the 3 into the parentheses, giving us 3x minus 3 plus 2. And now we just clean this up. Negative 3 plus 2 is negative 1. So this is the slope-intercept form of the same line. So there's 2 forms we can put it in. The slope-intercept form tells us the slope and the y-intercept. That's why it's called slope-intercept form. The point-slope form tells us a slope, and then it also tells us a point that's on the line. So that's why it's called point-slope. So they're just 2 different ways of writing the same thing, but we could easily find different pieces of information from the point-slope and the slope-intercept form. Okay. Now let's look at another example. let's find the equation of the line with slope 4 and y-intercept 0, 6. So we'll write the equation in slope-intercept form, and we'll also write it in point-slope form. But since we're given the slope and the intercept, the easiest way would be to just do the slope-intercept form, which is mx plus b. And we know the slope is 4. We know the intercept is 6. Sorry, my b and my 6 look the same. So plugging in, we have y equals 4x plus 6. And that is point slope, or excuse me, that is slope intercept. Slope intercept form because we have the slope and the intercept. I knew this intercept was 6, right, from this information here. X is 0, y is 6, so that means b is 6 if we use mx plus b. Okay, if we wanted to use point slope, we could have done y minus y1 equals m x minus x1. Right, so we have y minus 6 equals 4x, and then if we add the 6 over, we end up the same place here. So point intercept and slope intercept and point slope, they are the same thing, they're just jumbled around. We just jumbled our numbers around a little bit. Right, see, so this is point slope right here, because it tells you the point, it tells you the slope. But if you simplify the point slope form, you end up back at the slope intercept form. So that was the point of this exercise, to show you that these formulas do in fact describe the same line. They are just written slightly differently. Okay, so now let's see an example when we're given 2 points and we find the slope and the intercept. It was something I mentioned in 1.3 but have not solved such a problem until now. Okay, so for example, say we are given the points -2, 5 and 3, -5. Let's find the equation of the line that passes through those 2 points. These 2 points. Okay. Now if you recall from 1.3, we had the formula for a slope, which was change in y over the change in x. So that's what we can use to find the slope. And now we finally have a way to find the rest of the equation. We have this formula, the y minus y1 equals m x minus x1. So we can use both of these formulas to answer the problem. First we find the slope, then once we have the slope, so once we figure out the slope, we plug the slope in here, and then we could pick any one of these points to plug in here, and then we have the equation for the line. Okay, so this is step 1, this is step 2. So let's begin with step 1. We will find the slope. The change in y would be minus 5. Minus 5. The change in x will be 3 minus negative 2. So on top we have negative 10. On the bottom we have 5. That equals negative 2. We have a slope of negative 2. Okay, so we completed step 1. Now we move on to step 2. Right, so now we have a slope, and then we have 2 points to choose from. We only need one. It doesn't matter which one. I'll just pick this one. Okay, so I'll plug in a point. I'll do y minus 5 equals our slope mx minus negative 2. Right, so I was plugging into this formula. y1 is 5. M, as we found, is 2. x1 is negative 2. So that is how I plugged in here. Okay, now it's just simplifying after this. So y minus 5 on the left-hand side. We have negative 2, x plus 2, y minus 5. Okay, this is point slope form. So if we were asked to solve the problem in point slope form, we would be done at this step. But I'm going to go a little bit further and go to slope intercept form. So negative 2 minus 2x minus 4. And we add the 5 over, we have y equals negative 2x plus 1. This is slope intercept form. So sometimes in your homework you would be asked to write the equation in point slope, so your answer would be this circled in red. Sometimes you will be asked to write the equation in slope intercept, which will be the equation here circled in black. Now the slope intercept, in my opinion, is a little easier to graph. We know the intercept here is 1, right, 1. Slope is negative 2, so I'll go down 2 over 1. So we could graph this pretty easily as well. And there we have it. That is how we find an equation of a line if we are given 2 points. So it's a two-step process. Step 1, find the slope. Step 2, we plug into point slope form. Okay, so let me do one more example like this just to give us some extra practice. So I'm not going to write the whole thing down, I'm just going to write the points down to save some time. So 5, 0, negative 3, 6. So we'll find the line, the equation for the line that goes through these 2 points. Right, step 1, we find the slope. So we do 6 minus 0, negative 3 minus 5. 6 on top, negative 8 on bottom. Okay, we can cut both of these numbers in half if we want it to be a little more simple, and we'll have negative 3 over 4. The slope is negative 3 over 4, down 3 over 4. Step 2, plug into the formula. Now I'm going to choose to use this point because the number 0 is easier to work with than the number 6, right? But we could use either one of the 2 points. I'm just going to plug in the first point. So do y minus 0 equals negative 3 over 4, x minus 5. So y equals negative 3 over 4, x plus 3 over 4 times 5. Y equals negative 3 over 4, x plus 15 over 4. Right, you could think of 5 as 5 over 1. So 3 times 5 is 15. 4 times 1 is 4. Okay, so hopefully we are comfortable with point slope formula. Let me now talk about a different concept here. Let's talk about parallel lines and perpendicular lines. So I'll draw a picture here. I'll do parallel lines in blue. These are parallel lines. Perpendicular lines in red. Right, so that's a 90-degree angle. And these blue things are parallel. So by looking at this picture, you can notice that parallel lines have the same slope. Hopefully that is obvious just by looking at the picture, right? The rise over run is the same for parallel lines. That's what parallel line means. Now, for perpendicular lines, it may be a little more confusing to figure out how the slopes are related. Let me draw a different example of perpendicular lines. Let me do them like this. Right, so those are some perpendicular lines. Right, we have a 90-degree angle right there. One thing you can notice is this slope is positive, this one's negative. So clearly for two lines to be perpendicular, one of the slope has to be positive, the other slope has to be negative. That's one requirement for perpendicular lines. They also have to be similar or related. The slopes have to be related, right? If this slope here is going up 3 over 1, well, this one would have to go over 3 down 1 to be perpendicular. So let me write down the rule here. Perpendicular lines. Let's see, perpendicular lines have a slope. How do I want to word this? The slope of one line is the negative reciprocal of the other slope. Or we could say have slopes. Let's say M1 is a slope for one of them, M2 is the slope for another one, such that the slopes are related to each other in this way. So hopefully the minus sign makes sense, as we noticed one slope has to be positive, the other has to be negative to be perpendicular. And if you think about it for a little while, this does make sense. It's like what I was saying, if this goes up 3 over 1, this one will have to go over 3 down 1. That's all this equation is saying. Okay, so this is the relationship of perpendicular slopes, and the relationship of parallel slopes is easy. If this is m1, this is m2, they are equal. Okay, so let's do some examples here. Let's say we have some equations like this. These are, in fact, parallel. Why? Well, look at the slopes. They're the same. Okay. These are perpendicular. I'm just going to write perp from now on. It's a little easier to write. These slopes are perpendicular. Why? Well, this slope is the negative reciprocal of that slope. So one thing to notice from these two examples is that the y-intercepts are sort of irrelevant. We are only concerned with the slopes when we're determining if two lines are parallel or perpendicular. Okay, let's do a little more difficult example now. Let's find an equation of the line let's maybe do a two-part question. This is part A. Find an equation of the line that goes through the point 4, -3, and is parallel to the equation 4x plus 5y equals 7. And then for part B of this question, we will have it be perpendicular to 4x plus 5y equals 7. Right, so we'll have to keep these slope equations in mind. So part A, we'll find a line that goes through this point and is parallel to this. For part B, we'll find a line that goes through this point and it's perpendicular to this. Okay, let's begin. So for part A, well, we have a point, and what else do we need? Well, if you recall, we need a point and we need a slope. Right? We need a point and a slope to do this. Now, do we have a point and a slope in this problem? Well, we for sure have a point, and we are not given a slope, but we're given a condition here that we are parallel to this line. So that means the slope, right? The slope will be equal to the slope of this line. So we're given a point and we're given a line for which the slope of the line will be equal to the slope of the line we are interested in. Now, what is the slope of this line? Well, just looking at it, you may not see what the slope is. We have 4x plus 5y equals 7. Let's write this in mx plus b form. Let's write it as 5y equals minus 4x plus 7. Y equals minus 4 over 5 plus 7 over 5. Right, divide both sides by 5. Okay. Ooh, I forgot to write the x. Sorry about that. Okay, so this is the slope, right? It's the slope. So now let's think. We have a point, and now we have a slope. This number doesn't matter. Who cares about that number? We know what the slope we are interested in is. We know what the point we are interested in is. So now we can plug into point slope form. We do y minus y1 equals m x minus x1. Y plus 3 equals negative 4 over 5 x plus 16 over 5. Okay, right, I multiplied this in. 4 times 4 is 16, right? But we're dividing by 5. Okay, and I could minus the 3 over if I want to put this in slope-intercept form. So we have negative 4/5 x plus 16 over 5 minus 3. But let's write 3 as 15 over 5. Right, then we have y equals negative 4/5 x. Okay, and now we have 16 over 5 minus 15 over 5. So that's plus 1/15. Okay, this is slope-intercept form. And here, let me simplify this a little. Here is point slope form. Okay. Okay, so that's pretty much it for this section. The only other thing you need to keep in mind is just the material we've learned from previous lessons. So one thing you may need to remember when you're doing the 1.4 homework is that the slope of a horizontal line is 0. The slope of a vertical line is undefined. You may need to use this knowledge in 1.4. This is stuff we learned in 1.3. So, you know, we're building upon our previous knowledge. You may need to look back at your previous notes when you're doing the 1.4 homework, but that's how math works. We keep building upon the ideas. Quick recap of this lesson. We learned the point slope formula, and we learned this strategy for finding an equation for a line where we're given 2 points. First we find the slope, then we plug into the point slope formula. And we also saw that point slope and slope intercept, they're really the same thing, they're just rearranged slightly differently. And then we learned this fact about parallel lines and perpendicular lines. And I will end here for the 1.4 lesson. Thank you.